So in this video, we are talking about absolute value equations. And to save a little time, I posted already the steps for solving absolute values. But I think it would really help to actually know what an absolute value is. Technically, what an absolute value is just a distance from zero on a number line. So if I had, say, the absolute value of 2, that would mean that it is 2 units or 2 spaces away from 0 on a number line, which means that it could be 2 spaces in either direction. So the absolute value of 2 can be 2, but it can also be -2 because it is just a distance of 1, 2 on the number line in either direction. So that's ultimately what absolute values are, and it might help when you read these steps to understand that. Because if you look at the steps, it says isolate the absolute value. That means the only thing that you want on one side of the equal sign are those 2 lines that represent the absolute value and what's in between them. Nothing else. Everything else should be moved to the other side. Then it says create 2 equations by setting the inside, what's left inside that absolute value, to both the positive and negative of the other side of the equation. And the reason we do that is because we can have a positive and a negative absolute value, right? Because it is just a distance. All the negative means is which direction I'm going in, right? If it's a negative, it's going in this direction. And if it's a positive, it's going in this direction. But they're still the same distance away from 0 on that number line. Then we just solve both equations and write our answers as a solution set. And I'll show you how to do all of that. Again, just like the last video, I'm going to try and keep it short. That's all the explanation you're going to get, except for while I'm solving the problems. We'll do like 3 or 4 problems, maybe a little bit more. And then I'll have you guys do one at the end of the Edpuzzle, and you'll have an assignment in Delta Math. So for the very most basic of problems, if I have the absolute value of x is equal to 2, we've already kind of seen that, right? We know that that means I could take that x and it can go in 2 in this direction or 2 in this direction. But when we're solving it mathematically, it says isolate the absolute value. This absolute value is isolated. It is the only thing on this side of the equal sign, right? There's nothing added or subtracted to it, the outside of it. Everything that's on that side of the equal sign is between those 2 lines. So step 1 is done for us already. So now it says create 2 equations by setting the inside of the absolute value to both the positive and negative of the other side. What does that mean? It means the inside of the absolute value, well, that is x. X equals the positive of the other side, that's 2. X equals the negative of the other side, right? Then it says to solve both equations. Well, in terms of this problem that we're doing, both equations are solved. X is already isolated, right? We can just put a box on those, right? We know that that is our solution. But it says that we should write the answer as a solution set. And what that means is I'm going to have x equals the set of -2 and 2. So let's look at something a little more complex. What if I have the absolute value of 5z equals 40? So again, first step is done. The only thing that is on that left-hand side of the equal sign is that 5z inside the absolute value. If there's nothing on the outsides being added, subtracted, or multiplied to that absolute value. We're already isolated. So now we can create our two equations by setting the inside of the absolute value to both the positive and negative of the other side. We're creating two equations. One will be 5z equals 40, and the other one will be 5z equals negative 40. And then we're going to solve both these equations, right? We want the variable to be set equal to something. So here I have 5 being multiplied to z. So I am going to divide both sides by 5. And I wind up with z equals 8. Here again, I have 5z being multiplied. So I'm going to divide by 5. And I'm going to get z equals negative 8. And when I write my solution set, I am going to get, oops, I wanted to write x there, but that is not our variable. Z is our variable. I'm going to get z equals negative 8 and 8. I always write them in chronological order, right? If I have a negative, it's going to come before the positive, right? We want them to be in numerical order. Will they always be that simple? Heck no. They're going to get way more complex than that. What if I have the absolute value of d plus 1 equals 8? Again, we're already isolated, right? The only thing we have to do is set up our two equations now. We're going to get d plus 1 equals 8, and we're going to get d plus 1 equals negative 8. And we're going to solve both of those equations for d. Here, the only thing being done to this d is 1 is being added to it. So I'm going to subtract 1 from both sides and get d equals 7. Same thing's happening here, right? The only thing happening here is 1 is being added to it. So we're going to just subtract 1. And here I'm going to get d equals negative 9. And when I go to write my solution set, I would get d equals negative 9 and 7. Sometimes we are going to have to isolate it, right? Clearly that step exists for a reason. So let's look at what happens when I have the absolute value of c plus 2 equals 12. So if we look at this now, we can see that c is not the only thing on that side of that absolute value is not the only thing on that side of the equal sign. So before we can continue, before we can create our two equations, we need to move that plus 2 over. And so I am going to subtract 2 from both sides, and I will be left with the absolute value of c equals 10. Now I can create my two equations. I can have c equals 10, and I can have c equals negative 10. And when I set that into the set notation, I can call that negative 10 and 10 as my solution set. Let's get one that's kind of crazy. What if I have, trying to find the craziest one I've got here on the paper. Let's go with, I don't know what example that is. I stopped number 5. What if I have negative 10 times the absolute value of h plus 5 minus 3 equals negative 83. So the first thing we want to do is we need to start working on isolating that absolute value so that it's the only thing left. I have this negative 10 being multiplied to it. I have this negative 3 being subtracted from it. I'm going to start by what's being subtracted because we do backwards PEMDAS when we're isolating something. And so we would do the subtraction first. So I'm going to just add 3 to both sides. And I wind up here with negative 10 times h plus 5 equals negative 80. Now I still have that negative 10 being multiplied to it. So I'm just going to go ahead and divide both sides by negative 10. Once I do that, I'm going to be left with the absolute value of h plus 5 equals 8. And now we have something that looks a little bit more familiar, and I can create my 2 equations because the only thing that's on the left-hand side of this equation is the absolute value itself. And so we are going to write our 2 equations. We're going to go h plus 5 equals 8. And we're going to go h plus 5 equals negative 8. And then the only thing we have left to do is to subtract that 5 off of each of the h's. So here I have h plus 5, so I'm going to subtract 5, and I get h equals 3. Here I'm going to subtract 5 and subtract 5, and I am going to get h equals negative 13. And when I write it in my set notation, I'm going to have negative 13 and 3. Now that's as complex as a problem I think you're going to come up with on this, so you should be okay with that. The one thing that I want to point out, though, is we have a few special cases or special rules, I should say, and that one is that an absolute value cannot equal a negative number. Can't equal a negative number because as soon as we pull it out, it becomes positive because we're talking about that distance. So if I have the absolute value of x equals negative 6, this does not work. There is no solution for that. Does that make some sense? If I had, let's be more complex with it. Say I've got negative 3 times the absolute value of 2x plus 1 equals 21. And I start solving, and I go, okay, well, I've got to get this negative 3 off of here, right? So I'm going to divide both sides by negative 3 so that I wind up getting my absolute value by itself, 2x plus 1. 21 divided by 3 is 7, but it's going to be negative 7. And now that I have this absolute value all by itself, and it's set equal to a negative number, we know that that cannot work, right? We cannot have an absolute value set equal to a negative because once I pull it out, it becomes positive. And so again, there is no solution there. So I just want you to keep that in mind when you're solving them, that if something is set equal to a negative, you wind up having no solution. Again, there'll be a question at the end of this ed puzzle. Your assignment is in Delta Math. If you have any questions, do not hesitate to contact me. I'm happy to help.